Process. Assalamualaikum. My name is Azwana binti Yusof. I will present about the process flow diagram of bioethanol production. Bioethanol is a natural product and is manufactured by the fermentation of plants containing sugar and starch. In these plants, bioethanol produced from renewable raw materials and from raw alcohol of agricultural origin. At the plants, the production of bioethanol from starch-containing cereals takes place in 5 steps, which are milling, heating and addition of water and enzyme, fermentation of the mash using yeast, distillation and rectification, and lastly drying. Okay, at the milling, milling is the mechanical crushing of the cereal grains to release the starch components. And then the starch component will added with water and enzyme for conversion into fermentable sugar. And then at fermentation of the mash using yeast, whereby the sugar is converted into bioethanol and carbon dioxide. At distillation and rectification, concentration and cleaning the ethanol produced by distillation. And lastly, drying or dehydration of the bioethanol. Okay, bioethanol can also be produced directly from sugar syrups. This dispenses with steps milling and heating and addition of water and enzyme, which serve to prepare the grain for fermentation. Okay, that's all from me.
Assalamualaikum, my name is Nurzaida binti Zulkifli. I will explain about the production process of bioethanol. The production process is different as it incorporates a different energy concept and produce different food and animal feed products. Firstly, the wheat is cleaned and ground in a mill. The bran is separate from the wheat grains and is used to generate primary energy in a biomass plant. The next processing step separates the gluten from the rest of the grain. Then, by adding enzyme, the starch contained in the wheat is converted into fermentable carbohydrate, which can then be fermented into alcohol. Sugar syrup can be fermented directly. In next step, the fermentation process, yeast converted the carb.
For the fourth flow rate, which is fermentation, there are 2 flow rates enter the process under liquid mash. First, with flow rate 2.67 kg per hour with material balance sucrose 0.45 and water 0.55, while for the second flow rate is 0.61 kg per hour with material balance water with value 1, and the product that will go out from this process is fermented CO2 with flow rate 0.31 kg per hour. Material balance for water is 0.5 and carbon dioxide is 0.5. And for the fermented mash that will go out from this process with value of flow rate is 2.97 kg per hour with sucrose 0.6 and water 0.4. And for the fifth process, which is distillation, fermented mash enter this process with flow rate 2.97 kg per hour with sucrose 0.6 and water 0.4, and the product that will go up have 3, which is wastewater with flow rate 0.21 kg per hour with water 1, ethanol flow rate 0.32 kg per hour with material balance sucrose 0.74 and water 0.26. And the last one is solid from B column with flow rate 2.44 kg per hour. Material balance sucrose is 0.76 and water 0.24. That's all for
Assalamualaikum warahmatullahi wabarakatuh. Now I want to explain the process of distillation by bioethanol. And then now this state is solid separation, which is the it state G. From solid separation, the solid from B column from the distillation will enter the solid separation with the mass flow rate 2.44 kg per hour. And at this mass flow rate, we have sucrose, which is it has the mass fraction 0.76 and H2O 0.24. And then after that, the separation will separate into two parts. First part thin stillage, and the second part is with K. And for the thin stillage, we have the mass flow rate 1.85 kg per hour, and then the mass fraction for water 0.22. Then for sucrose is 0.78. And then the another part is the wicket, which is solid separation. We separate the component will go to the dryer. And at this state is the mass flow rate is 0.59 kg per hour, and the sucrose is 0.62 and water 0.38. After that, after the solid separation, we will go to the evaporator. Then this state is the thin stillage. From the thin stillage, it will come to the operator, and then operator will separate into two parts, which is for wastewater and the syrup. For wastewater, we only have the H2O only, and the total of mole fraction is 1. Then the mass flow rate is 1.48 kg per hour. And then for the syrup, from the evaporator, the syrup will transfer to the dryer. It has the mass flow rate 0.36 kg per hour, and H2O 0.15, then sucrose 0.85. From the dryer, we have the two input. Then also we have two output, which is the input from the syrup and with cake. The syrup that I has explained just now. Then for the its output is for wastewater and TDSR. For wastewater, just it's same, but the mass flow rate is 0.62 kg per hour. Then for DDSR is the dried distilled grains with soluble. Is wet distilled grains that has been dried by with the concentration thin stillage. After that, for the scrubber, the scrubber is come from the fermentation. It has one input, and two input and two output. The input is from fermented carbon dioxide and the water. For first input, it has the mass flow rate 0.31 kg per hour, and the mass fraction for H2O 0.5 and carbon dioxide 0.5. water, just only have water mass fraction, which is 1, and the mass flow rate is 0.17 kg per hour. And then for the output, we have CO2 and wastewater. Then the mass flow rate for both this output is 1. Is the mass fraction for these two output is 1, and for the CO2 mass flow rate is 0.31. Then for the H2O 0.17. Then solid separation. Solid separation is it means to separate the two component or more component or amount of liquid. Then for the evaporator, it's to allow the compressed cooling chemical to evaporate the liquid to gas by absorbing heat in the process. And then lastly, for scrubber is two diverse group of air pollution control device that can be used to remove some particulate and or gas from industrial exhaust stream. Okay, that's all the process of distillation by bioethanol.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Zafira binti Marohim. I would like to present about several factors. One of the several factors is temperature. Temperature is one of the most important factors that affect the ethanol production by yeast using molasses as a carbon source. The fermentation process is always accompanied with evolution of heat that raises the temperature of the fermenter. Ethanol fermentation at enhanced temperature is a main necessity for effective ethanol production in tropical region where normal daytime temperature are typically high all over the year. The rewards of rapid also reduce the cooling cost. To attain enhanced temperature fermentation, it is essential to use an competent yeast strain that can tolerate high temperature. For bioethanol production at higher temperatures, yeast cell die resulting in a cutback in alcohol yield when the substrate is concentrated, while excellent temperature for maximum productivity occurs at 32 Celsius degree for maximum strength. It is therefore necessary to select the optimum temperature at which yeast strain can ferment the sugars. Taking into consideration the strain for temperature variation to be carried out, there is a requirement of thermotolerant strain that can withstand high temperatures during the experimentations. For example, K. marcianus is considered to have an optimal temperature at the temperature of 40 Celsius degree at which it can grow and ferment, but if temperature is reduced to 28 Celsius, then also it shows growth at a better level as compared to the increase in temperature of the same species till 48 Celsius at which minimum fermentation might be possible. Hence, temperature plays most important operating variables in temperature. The dependency of the maximum ethanol production rate on the temperature was explained by the superposition of activation energy for ethanol production. That's all.
Assalamualaikum. My name is Nurul Amira binti Edi. The second factor is genetic engineering. Genetic engineering technology present undeniable for future agriculture and biofuel production. It has been focused will be on the various possibilities that genetic engineering can offer to increase bioethanol production at large level. One strategy is to modify the characteristics and properties of yeast so that they can be converted more readily to the desired product. Enhanced stress tolerance in plant has been achieved mainly through the manipulation of effector gene. To categorize gene that could be existing target for succeeding genetic engineering directing to obtain more robust and vigorous industrial yeast gene in industrial strain will be next logical and reasonable step. To find out even if this influence may lead to the generation of supplementary robust industrial strain. which will be capable to deal with the most important fermentation tension and thus to boost ethanol production rate and final ethanol titers. Combining different type of enzyme and genetically engineering new enzyme that work together to release both hemicellulosic sugar can be termed bioprocessing. Genetic engineering is playing a major part in getting the best possible conversion rate in thermotolerant yeast. Biotechnological advance, especially in genetic engineering of commercially useful enzyme producing strain, are playing an important role in solving some of the bottlenecks that occur in production and will be vital in securing cellulosic ethanol as a competitive liquid fuel for the future. In coming years, genetic modification of crop used for biofuel production will be done by modifying quantity or quality of biomass.
Assalamualaikum, my name is Nur Askiza Sharina binti Bahtiar. The third factor is incubation time. The cell increased exponentially at the beginning of incubation, then entered a stationary phase after several days incubation. It is very important for the growth of the yeast so as to promote the production of ethanol. Considering the work of Tri-CCV, incubation time is being focused that ensure the incubation duration consumption of reducing will increase, indicating the level of reducing sugar in the medium is gradually and progressively decreasing. This means that longer the duration of fermentation, increased amount of sugar will be used by microbes to grow and produce primary and secondary metabolites. Standardization of incubation time will positively help in the growth of metabolism of the organism, but coin having its two sides, the incubation should not exceed a proper limit since after the stationary phase, the growth curve moves towards the decline phase where the cell numbers start to decreasing, indicating the completion of the nutrient media. It is very important at the industrial level to produce ethanol at low cost and minimum time. This is the reason for which incubation time